the gold leaf electroscope. So when we're working with charges, it's very difficult for us to actually see if something is charged or what kind of charge that it has. So there are certain devices that exist that help us to detect if there is a charged object or a neutral object. It also helps us to decide what kind of charge that object has. So before we start or get into it, we first need to understand the forces that exist between charged objects. So we know now that if I've got like charges, okay, so we understand that like charges, they're going to repel each other. So if I look at two positive charges or two negative charges, they're going to experience a repulsion. If we have a neutral charge, if we have two neutral charges, there's no force between them. No attraction, no repulsion. And if we have unlike charges, then we have attraction. So that's the first thing that we need to understand. That if objects are charged, there exists forces of repulsion or attraction. And if they are not charged, then there are no forces of attraction or repulsion that exist between those things. So the main part we're looking at here is the electroscope. So I'm just going to go through the different parts of the electroscope and what those parts mean. So the first thing we have here is the brass disc. Now the brass disc is made out of a metal, so it's a metal. And the charges are able to move easily through them because it's a metal, it's a conductor. So that's the top part of the electroscope. Then you've got an insulator plug, and that really ensures that none of the charges are moving around freely on the inside. Then you've got a glass case. Now the glass case is not just randomly glass. The first thing is it's an insulator, okay, and it allows for charges to remain in the electroscope. So it creates almost like a vacuum. That means there is no air or particles of matter. That just means that there's no excess charge that's going to enter this whole system. Okay. And the next thing that you have is the next part that's actually just part of the experiment or part of the setup is the metal foil. And the metal foil is to assist with grounding the system. Okay, so it also, it's more to help with the glass to be grounded. Okay, grounding, remember, is earthing, which is just making sure that the whole system is connected to the earth, so there's no excess charge coming from anywhere, or there's no charge build up, so you don't get electrocuted when this happens. The next thing we look at is the gold leaves. Now the gold leaves, they are made out of gold, and their purpose is to interact with the charges. So when I say interact with the charges, remember the purpose of this gold leaf electroscope is a device to tell us whether something is charged or it's not charged or it's neutral or whatever the case is. So it interacts with the charges that are introduced to it. And it's able to tell us whether something is charged or not charged by the movement of the leaves. Okay, so the leaves can move. Now, how they move is dependent on what charge is present. So we can either say that the leaves converge, and you'll hear me using that word, which means they come together, or they come closer to each other. And it works on the same principle of attraction and repulsion. Or they can diverge, and that just means they move away from each other. So when we started this little section, we had a look at the laws of attraction and repulsion, and we made a statement that unlike charges are going to go through attraction and like charges are going to repel. Same thing here. Converging, come together, there's going to be attraction, and divergent is when we have repulsion. Alright, so you need to be able to look at the code of electroscope, label it. So I would suggest that you draw this in your book, and then they can ask you in a test or an exam to maybe discuss the purpose of each of the parts of the electroscope. What's their function? They can ask you to label the diagram. They can have all the labels blank, and then ask you and give you letters like X, Y, Z, and ask you to label and to give the function. So it's important that you get this into your books. Then remember, the electroscope or an electroscope can be used to find the nature of a charge and measure the charge on a body. So those are the things that we're going to look at. How do we use the electroscope to find out if there is charge? How do we use an electroscope to find out whether something is positively charged or negatively charged? And the last thing we're going to look at is how do we charge an electroscope? Okay, and there's a reason why we need it to be charged. And as we go through, you're going to learn about that as well. All right, so the next thing is detecting charge. For detection of charge, the object has to be tested. The object that's going to be tested is brought slowly near or in contact with the uncharged electroscope. So if I have an uncharged electroscope, the leaves are neutral, so they're not diverging or repelling or converging or attracting. So the leaves in this situation are basically resting. Now, if I bring a charged object close to or in contact with the disc at the top, two things can happen. If the object itself is charged, so what I want to actually do is I want to bring a charged object, a random charged object, or a random neutral object, any kind of object. I'm going to bring it close to this brass disc here at the top. Okay, so one of the things that can happen is if the object is charged, then the leaves are going to be deflected. Deflected just means movement. Okay, they're going to shift. I'm going to talk about what you'll actually see in a bit. If nothing happens to the body, as in there's no movement, when you bring the object close to the brass disc, if there's no movement, that means that object is uncharged or neutral. So this is how it works. So what I start off with is a neutral electroscope. Now all three of these are neutral electroscopes. So when I look at the arrangement of charge, the arrangement of charge in a neutral electroscope looks like this. So there we go. If you can have a look around the leaves all of the charges around there should be equal. So there's equal amount of positive charges, equal amount of negative charges. When you bring an object then close to the top, there's an interaction. So there's going to be an interaction between the brass disc and the rod. Okay. And that interaction deals with the forces of attraction and repulsion. So it says here that if I bring an electroscope is approached with a negative rod, right? So what happens if it's a negative rod is that, just gonna make, you have to get these drawings into your books. So if you have a negative rod, right, what happens is it attracts all the positive charges that are around the leaves. Okay. So all the positive charges, they go up to the top and they go closer to the rod. So what you have at that point is your polarization. Okay. Now when that polarization occurs, the second thing that's going to happen is that the leaves, because the positive charges are at the top now, the leaves are both negative. Now, if they're both negative, they will repel each other. Now, that's just if I bring a negative rod around a uncharged or neutral electroscope. That's what's going to happen. If I bring a positive charge, so if I bring a positive charge, the same thing happens, except the charge interaction is different. This time, because I brought a positive charged rod close to the top there, the negative charges, right? Negative charges from the leaves are attracted to that rod. And because they attracted to the rod, they also move up. Okay, so they're going to move up to the top. Okay, once that happens, again, you have polarization. Now, because of that polarization, the leaves in this situation are both positive. And because of that, they will repel each other. Now, if you can notice now, if I am using a neutral electroscope, it can only tell me that there is charge present. It cannot tell me what type of charge, because in both instances, there's repulsion. In both instances, there is converging. So I want to know now specifically, if I want to know what kind of charge is being brought forward, right, I need to make sure that the electroscope is actually charged. So again, if I had to bring a neutral object to a neutral electroscope, there will be no movement at all. So that will tell me that the object that I brought close is neutral. So you'll notice that the leaves stay at rest. Okay, they're in a relaxed position. So because if I bring a positive or a negative rod close to a gold leaf electroscope that's neutral, in both situations, there is going to be convergence. And that's a problem, because that means if the result is the same, I can't tell whether I have a negative charge or positive charge. So what needs to happen is the electroscope actually needs to be charged. Okay, the next thing we're looking at here is identifying the nature of the charge. So like I said previously, if I have a neutral electroscope, it doesn't tell me the nature of the charge. It only tells me that there is charge. what needs to happen is, if you want the nature of the charge is whether it is a positive or negative object. Okay, if you want to know whether it's a positive or negative object, you have got to bring the body or the object close to a charged electroscope. So the electroscope has to be charged, which means we have to use our methods of charging. So here you can either do it through conduction, and that means the object touches the brass disc, or you can do it through induction, where there is the object does not touch the brass disc. Same concept, it's just close to same concept as induction itself, using grounding close to. And what we want to do is we're going to use a grounding device. Okay, so the first one that we're looking at is charging by conduction. Now, like I said, in an exam, they will give you these 4 diagrams, or they can ask you in 4 steps, show how you can charge an electroscope using conduction. So we're using the same principle of conduction. We, instead of having 2 spheres or a sphere and a rod, we have a rod and an electroscope. Okay, so the first thing you're going to start off with, I'm going to just break it down into 4 steps, right? In the first step is you have a charged, let's say a charged rod, and in this case, it's a positively charged rod. You can have a negatively charged rod as well. The electroscope is neutral. Electroscope. And what we want to do is we want to charge this electroscope. Okay, so in step 1, you start off with a charged rod and a neutral electroscope. In step 2, what you want to do here is you want the charged rod must touch the brass disc. Okay, so there must be contact. So what's going to happen then, when it touches, you're going to end up with polarization. Okay, because the negative charges around the leaves are attracted to the positive rod. And because they're attracted to the positive rod, just going to write that here, the negative charges move to the top. Okay, once they get to the top, the electrons or the negative charges flow onto the rod because they have attraction. And there's also, so you have attraction and you have contact. Okay, so initially when you started off, you had a situation where the electroscope itself was neutral. So in an exam, they can ask you to draw this out in the 4 steps. The second thing happens, it touched, and what you happen to have here is a polarization. So closer to the leaves, the charge is positive, and at the top, the charge is going to be negative. Then what happens in step 3? The negative charges, because now there's contact, they have a pathway to flow in, they will all join onto the rod. Okay, once that happens, in step 4, the rod is removed. First, the rod is removed, and the second thing that happens is your electroscope has a positive charge. Okay, so once that has a positive charge, the positive, remember what I said, because they're all positive charges and they repel each other, the positive charges distribute themselves equally all over the electroscope. Okay, so now you end up with a positively charged electroscope. All right, then we're going to use that positively charged electroscope to see what kind of charge my random object has. Okay, I'm going to show you induction, and then I'm going to show you all the rules that come with whether it's something negatively charged is brought close to a positively charged electroscope, what happens to the leaves. If a negatively charged object is brought close to a negatively charged electroscope, what would happen to the leaves? So in this one, we had a charged rod with positive and a neutral electroscope, but you can make a note for yourself that the charged rod can be negative, but the electroscope will have a different charge at the end. Okay, so that's using conduction. Now the next one is charging by induction. And you want to get these diagrams into your books and practice drawing an electroscope and drawing the setup, because in an exam or test they can ask you to show the process in 4 steps. You need to know what each process looks like at each step, and then they're going to ask you to explain each step. So you're going to want to do this for yourself, and just for practicing purposes you need this to be in your books. Okay, so charging by induction, we know that there is no touch involved in these situations. So the rod cannot touch the electroscope. Okay, so there's 4 parts to it. Again, there's 1, 2, 3, 4 steps. So the first step is you still start off with a charged rod. In this case it's also positive. Then you have a neutral electroscope, and the rod cannot touch the electroscope. In other words, it's just brought close to. Okay, so the first thing is, that's what you start off. Second step, when the positively charged rod is brought close to the electroscope, it causes polarization. Okay, so the negative charges or we can even call them electrons, move upwards to the brass disc. Okay, and the leaves have mostly a positive charge. Okay, so now remember those negative charges either need to leave or we need to get more negative charges. Okay, so in the other one, they left and they joined onto the rod because there was a pathway. Alright, so then step 3, what happens? I'm just going to do step 3 over here. Is that the sphere, or let's say the electroscope, is now grounded at the at the brass disc. Okay, so we now using a grounding. Okay, so you can call it a grounding or earthing device. Okay, the earthing device or grounding device allows the negative charges from the earth to come up or come into the electroscope. Okay, so they're coming from the earth and they move upwards and they go towards the electroscope. So now what you end up with, there is a build up of negative charge at the top. And the reason why the negative charges come into the electroscope from the earth is because they are attracted to the rod, okay, which has a positive charge. So they have a force of attraction. Right, so once you've got a buildup of negative charge at the top, step 4, you need to remove the grounding device. Same as when you do normal induction with spheres and rods. Remove the grounding device, then you remove the rod, then the electroscope will have a negative charge. Okay, yes, it will still have positive charges, but it will have an excess of negative charge or electrons. Okay, so those are the 4 steps for charging by induction. You start off with a charge rod, neutral electroscope. Again, in this example, we're using a charge rod that is positive. A negative rod can be used, but the electroscope will then have a different charge. But the process is exactly the same. So you start off with a positively charged rod, neutral electroscope, bring it close to the top. All the negative charges are going to come upwards. So let's just have a look here. So remember, when you start off with the electroscope, it's neutral. It's completely neutral. Right? There's an even amount of positive and negative charges. So this is neutral. Okay. Then what happens is when you bring that rod close by, all the negative charges go to the top. So they come from the bottom all the way up to the top of the brass disc. When you have that polarization taking place, then the leaves themselves will be positively charged for that moment. Once that's done, you attach the grounding device, and the positively charged rod is going to be attracting. So these negative charges are attracted to the positively, so the negative charges are attracted to the positive rod. Okay, they go up. Eventually you have a buildup of electrons at the disk. Once that happens, you remove the grounding device, remove the rod, and your electroscope is then negatively charged. And that's how the gold leaf electroscope can be charged by induction. Now we've got to look at how will the gold leaves behave depending on what kind of charge is brought close to it, and how will we be able to use that electroscope to then determine whether the object that has been brought forward is a positive or negative. And for that, we need the electroscope to be charged. Right, the last thing that we have to look at is how do we actually use the electroscope. So when we have the electroscope that is charged, we can then use that electroscope to determine the nature of the charge. So two concepts that we have to keep in mind. One is the term of attraction. Attraction means that the leaves will come together, and that means to converge. Repulsion means the leaves go apart, and that means to diverge. That's just some terminology. So using a charged electroscope to find the nature of the charge. So if I have an electroscope that is positively charged, and I bring a charge that is positive, so positive and positive, what's going to happen is you're going to have a divergence. So it's going to diverge. So it's going to go apart. Okay. Because it's going to experience repulsion. If I have a negative electroscope and I bring a negative charged object, then I'm also going to get a diverge. Okay, the reason for that is negative and negative repel each other, so you're going to get diverge. If I bring through if I have a positive again electroscope, but this time instead of another positive, I bring in a negative charge close to it, we are going to get a converge, because positive and negative attract each other, so they're going to come close to each other. If my electroscope is negative and this time I bring through a positive charge, again, negative and positive mean attraction, so I'm going to get a converge. So the leaves are going to come close to each other. And for the last one, if I have a positive, okay, or I have a negative, okay, so whether it's positive or negative, and the object itself is uncharged, neutral, so it can either be uncharged or neutral, then whether it's positive or negative, that the electroscope, and you bring a neutral or uncharged, there is going to be no changes that take place. There's no interaction. So that is the gold relief electroscope and the different parts of it. What's the different parts of it? What's its purpose? How do you use it to detect charge? How do you get it to become charged using induction and conduction? And how do you then use the electroscope to decide whether an object is positive or negatively charged?